Hi, welcome to another EC&M Tech Talk. Today we're going to talk about NEC Article 408, Switchboards, Switchgear and Panelboards. So we're going to divide this up into 5 different sections. In the first section we're going to talk some general information about panelboards, okay? And then we're going to move into the marking requirements found in Article 408, really and elsewhere in the code as well. The next thing we'll do is we're going to take a look at the requirements for the circuit directory. It may be more than what you're thinking about right now. We'll do that in Section 3. Section 4, we're going to take a look on the inside and we're going to see what the panel board really is and what its requirements are. And then finally we're going to wrap up in Section 5 and we're going to talk about some of those installation requirements, some of the issues that you might run into out in the field that are not found in Article 408, but that are certainly important to us when we come to installing our panel boards. So let's begin and let's start talking about panel boards. This is not a panel board. This is the panel board. Take a look in Article 100 in your definitions. See what the definition is for panel board. You'll actually find 2 definitions, one for panel boards, one for enclosed panel boards. But nonetheless, the panel board is what we often refer to in the field as maybe the guts, okay? What's on the inside. The panel board has buswork on the inside. It has overcurrent protected devices or switches of some kind, and of course terminations and so forth. So that's what the panel board is. We're going to look at requirements for panel boards. In Article 408, then we find the general information on panel boards, and it's in Part 3 of 408 that we actually find the specifics for panel boards themselves. Back in the definitions in Article 100, it tells me that a panel board is either going to be mounted in a cabinet, a cutout box, or an enclosure. Of course, we're mounted in a cabinet here. By definition in Article 100 of a cabinet, I can mount a cabinet either on a surface like it is right now, or I can certainly mount my cabinet and panel board flush with the wall. Now, I'm going to have a cover on it as well, so we're going to talk about that then as we move into marking requirements. So let's move into Section 2, marking requirements then. So I'll just hold up a cover here of this particular panel board. A couple of things that we have to have on the cover of our panel board. And other than dwelling units as a requirement, whoops, there goes the door. But anyway, and other than dwelling units, 110.16 of the NEC says I have to have an arc flash warning label on my equipment. That label is going to have 2 bits of information on it. It's not required in 110.16, at least not in the 2023 code that we're talking about today. But 110.16 says, hey, an equipment that's likely to require, and panel boards are included, in other than dwelling units, it says I have to have an arc flash warning label and go to the NFPA 70E standard. The informational note says if you want to know what information has to be on the label. Basically, it's 2 bits of information, right? It gives us the shock information, and then so that we can protect ourselves by wearing the properly rated, voltage rated rubber goods and so forth. When we, pull the panel cover off is one good example of having to take proper protection there. And certainly if we're going to do anything, any voltage testing or work inside the panel board. So we need that voltage rating, the nominal system voltage on our label so we know what type of voltage protection we need. Now, and also it'll play into our barriers and maybe our barricades that we have to set up. The other bit of information that we're going to need on on the front of the panel board, on that arc flash warning label, is the actual arc flash information itself. In other words, in these, I always say the unlikely event, sure do they in degrees Fahrenheit or anything like that, they give it to us in calories per square centimeter. We have to make sure that the clothing that we wear is rated for at least that rating or above whatever that arc flash energy is that's going to come out of there. That's going to protect us. As we go through and we talk about our markings on our panel boards, this is just a piece of label tape put on here that tells us this is LP2A or whatever it says. That's generally not good enough. If we look through the requirements for panel board markings that we're going to find in 408 and 110 and so forth, but the general requirements that it talks about any marking that I put on the cover of that cabinet, cutout box or whatever, okay, whatever cover I put on that panel board as we call it, Those markings are going to have to be durable. They're going to have to be suitable for the environment. They're going to have to be legible. One specific location says they can't even be handwritten. I can't, even if I've got a beautiful handwriting, which I don't, hey, I can't take out my black Sharpie, right, and nice and neat and print on there one of the requirements that I have in 408.4. 408.4 says I have to put the source of my supply in other than 1 and 2 family dwellings on my panel boards, then my multifamily dwellings, commercial, industrial facilities, and so forth. I have to put the source of supply, and it has to be specific. It has to say, for instance, it's switchboard circuits 2, 4, and 6, something like that. So I need that specific information on there for the location of that equipment or that feed, and it's got to be permanent, meaning that things like putting a nice, pretty label on there that just, sticks on with some adhesive is not permanent. So what do I really need? Probably need to think about something like getting those little black nameplates with the white letters etched into it, and then you permanently attach that to your face of your panel board. So anyway, consider that all of your marking requirements. Now, other marking requirements that I have are found in 408.3 if I have a high leg. So in a high leg, if I have a supplying, let's say, this panel board, this is a single-phase panel board. So I could have a delta transformer supplying my single-phase panel board. I would go to one of those phases on that delta transformer, on the secondary side, of course. I'd go to one of those phases on the secondary side, and I could connect a red wire and a black wire to each end of one phase and bring that in, and that would be my ungrounded conductors coming into my panel board. I could go right to the center and attach another wire, and I would also ground that connection, right? So now I'd have a grounded conductor. By definition in Article 100, it would be a neutral, and I would take that neutral and run that into my panel board. So what do I have? Looking at my delta transformer, reading from either the black or the red, from either the bottom left to the bottom right phase to the neutral, I get 120 volts. That's great. But if by accident I go to the top of that delta connected transformer and I grab that wire and connect that ungrounded conductor with the neutral, I've got 208 volts. Surprise if I'm wiring up some receptacles, isn't it? Or a 120 volt motor, lighting, whatever it is. I've just probably burned up some equipment. I made the smoke come out of it, right? And that's not good. So 110.15 says if I have a high leg like that, what we're describing, that's that leg up on the top, I have to identify that high leg by either orange or some other effective means, which is, I've always seen orange anyway. So we make that conductor orange. That way when I go into that J box and I reach up there and I'm looking, I need a neutral, that's the white wire, that's easy. And let's see, I need a phase conductor. Oh, be careful, don't grab the orange one. Because if I grab the orange one, I've got 208 volts now going to my 120 load. So the requirement for the high leg marking, we go back to 110.15 in addition to 408.3 and find additional information on that. So that's an important one for us. And the high leg, by the way, must always be B phase on the 3-phase panel board. Let's take a look at the 3-phase panel board and see what that looks like on the inside then. So I have 3 separate buses. Article 408 says on the 3-phase panel board, those buses shall be from left to right, phases A, B, and C. And if I'm going to take a high leg, if a delta is supplying this panel board, then the high leg must be phase B as well. Okay, so phase B, orange in color. Hey, while we're here, notice on that panel board, if I plug in a single pole breaker over on the upper left-hand side, that's going to come off of A phase. If I go right below it and plug in another breaker, that's just going to plug into B phase. It's the way the bus work is arranged. If I take another breaker and plug in right beneath that second one, that connects to C phase. On the left-hand side of my panel boards, and sure on the single phase as well, but on the left-hand side are going to be all of my odd-numbered circuits, 1, 3, 5, 7, 9, 11. So what I just described to you, with those 3 separate circuit breakers, individual single-pole breakers, I have phase A, phase B, phase C. I have breaker 1, breaker 2, breaker 3. And if I'm color-coding them by industry practice, not required in the code, but let's say I use black and red and blue for A, B, and C. So what do I have? I have circuits 1, 3, 5, black, red, blue, A, B, C. And the same is true on the opposite side. I have my even numbers, 2, 4, 6, black, red, blue, and so forth, all the way down throughout my panel board. On this particular panel board up on the screen, it says it is designed for 84, maximum of 84 overcurrent protective devices. There has to be some way in the panel board, it's required by the code, and really it's part of the manufacturing and design, so that you can't put, for example, more than 84 circuit breakers in that panel board. That's a lot anyway, isn't it? Okay, so those are the marking requirements that I'm looking for then. In the next topic, let's move into that circuit directory. Now, the circuit directory, the requirements for the circuit directory, let's see here in my 2023 NEC, it says that circuit directory requirements are found in 408.4a. So 408.4b was what we just described, where the source of supply and other than 1 and 2 family dwellings, switchboard 06, whatever, you know. So that's 408.4b. .a is on the circuit directory. So I have to have a circuit directory. And where do we usually find that circuit directory? You already know this, right? Oh, if I open the door, there it is on the inside. Does it have to be there? No. Oh, it doesn't? Where else would you put it? I don't know. Look at 40.4a. It tells us. It says it is located on the face of the inside of or in an approved location adjacent to the panel door in the case of a panel board. So I don't have to have it inside the door. It could be adjacent to the panel board somewhere, an approved location. Where do we always find it? Inside the panel board. Now, if we look at the rest of those requirements in 40.4a, here's what it's telling us on the directory requirements then. It's got to be clear and legible, suitable for the environment. The big thing, and probably one of the big violations that we run into, in fact, EC&M magazine did do a survey several years ago about some of the most violated, sections of the code. And I think the circuit directory issue won. But anyway, we see a lot of problems with circuit.4a. It says, hey, look, don't make them generic. I can't put on my circuit directory, put the kid's bedroom. Why? Because 5 years from now, the kid's bedroom will be Charlie's bedroom or whatever, okay? So we can't use that generic marking. It would need to say something like receptacles, northwest bedroom or whatever. That would be maybe a good one. The same is true if I have a, let's say a commercial, an office building or something like that. I don't want to put on there receptacles, Mary's office. Mary gets promoted next month and she goes up into the high rise somewhere, okay? And all of a sudden that doesn't mean anything to me. Mary's office. So what I need to do is I need to put something like room 201 receptacles. Now I know. Also, it tells me that if I use any type of abbreviations or symbols or something like that as part of my circuit directory, I have to identify that on my circuit directory so people know what we're talking about. And we do that a lot, actually. So let's say that Mary's office is actually room 201 in building 2. So maybe we designate that as 2-201. But we have to identify however the heck we're doing, whatever we're doing, we need to make it clear to people so that when they look at that circuit directory, they know what breaker to go shut off. That's important for 2 reasons. One is an emergency. There's smoke coming out. Quick, there's smoke coming out of the coffee pot. Somebody quick, shut the breaker off. Okay? Well, gee, I wonder which one it is. It needs to be clearly marked for me. The other is, and maybe more typically what we would use it for, is lockout, tagout. I need to replace those receptacles, a couple of those receptacles on the south wall. Oh, I wonder what breaker it is. Well, let's keep trying until we get the right one. That's no good. It needs to be clearly marked. Room 201, receptacle, south wall. Now I know what I'm doing, right? Still going to follow all my requirements and verify the circuit's de-energized, but nonetheless I can do a much more effective job in my lockout tagout process. So circuit directories are very important to us for safety. Okay? And the next thing let's look at the insides of this panel board and a couple of the things that we should maybe pay attention to. One thing is the panel board, it's made of metal, so it's required to be bonded to the metal enclosure. Well, it's done that, when they actually mount it, the screws go through and mount to the metal enclosure. So that's not really an installation problem for us, unless we are allowed to, by the way, replace panel boards. We could pull the guts out and replace it with either listed or other than listed. It's all covered in the code. We can do that. We cannot recondition panel boards. 408.2 talks about reconditioning requirements. Panel boards cannot be reconditioned. So anyway, it's bonded to the metal enclosure. That's good. But this particular panel board, it tells me on here that it's suitable as service equipment on one of my labels. That means that when I buy it, it comes with a main bonding jumper. That's the green screw over here on the neutral bus. So when I buy it, that screw is probably not screwed in. And the neutral bus is insulated from the metal enclosure. But when I screw that screw in, it goes through the neutral bus and makes contact with my metal enclosure, bonds it to the metal enclosure. The equipment grounding bus bar is already bonded to the metal enclosure. So what have I done? I've taken my incoming neutral that goes to my neutral bus bar. I've taken all my neutrals as well, whatever's attached, and I have connected them to the metal frame and the equipment grounding conductor. I bonded those three things together. So we call that the main bonding jumper, and it's all covered in Article 250. Now, on grounding and bonding. If this is being fed from a separately derived system, it's not a service anymore, separately derived system. So in that case, we don't call that green screw the main bonding jumper. It's the system bonding jumper. Righty? Now, where we run into problems is when people go to a sub panel. So now this is being fed maybe from my main panel upstream, wherever it is. This becomes a sub panel. If I go ahead and screw that green screw into the panel and connect the neutral bus bar now to the metal frame of my equipment, there's a path for current flow. Current returning on my neutrals from my loads can now flow what? Into the neutral, into the metal frame of the equipment, through the equipment grounding conductors and back to the main panel. I don't want that to be a normal current carrying, path for current flow. That's a violation of 250.6. 250.6 talks about objectionable current. And so what do I have to do? I have to remove that bonding jumper in my sub panel then. So pay attention to those requirements. That can get you into a lot of trouble really quick. 250.6 then. Also something else, 230, Article 230, these yellow things up here have to be there. It doesn't say these yellow things. 230.62, Article 230 is on services, and it says on service equipment. Think about it. I'm going to come in here and grab one of these meters and maybe do some voltage testing for lockout, tag out, or whatever it is. Just do some troubleshooting, and I need to read some voltage in here. I don't want to be in here reading voltage and accidentally touch one of these terminals that attach to my ungrounded conductor. Even if I shut the main breaker off, it de-energizes the bus work, but it certainly doesn't de-energize the incoming conductors. I am required to have overcurrent protection on a panel board. That overcurrent protection can either be at the source of supply or right down here inside the panel board with this main breaker. So when we purchase this panel board, it comes with these barriers in it, and 230.62C once again said that these barriers have to be installed over those main terminals. So that way when I'm in here working, I don't inadvertently touch those main terminals and injure myself. So I think that's a pretty good requirement, been in the code for a little bit. Now, a couple other things we find in Article 408. In Article 408, it says, hey, when you bring these conductors in, you got to have enough room to deflect them, right? And bend them and put them into the terminals and so forth. So it actually refers us back to Article 312 on cabinets and cutout boxes and so on. Article 312, Section 312.6 is titled Deflection of Conductors. And it has two tables in it that tell us, based on the size of the conductors we're bringing in, their number of conductors per terminal, and whether I'm bringing them in straight into where I'm going to terminate them, or whether I'm bringing in from the side and have to deflect my conductors and so forth. Based on all of that, I look in my table based on the size of those conductors and read across to the right, and it tells me how much space I must have to deflect those conductors in. So that's 312.6. Take a look at those tables as you need to. Another issue is closures. Article 408 says I must have closures. So for instance, and I know you've seen it right all the time, you see on a panel board where there's a circuit breaker has been removed and you've got a hole now. and a slot, an empty slot. And so I could go in and easily stick my finger in there and contact some live bus work. Obviously very dangerous. So I have to use an identified closure. You have to go to the manufacturer for your panel board, right? Because those are the ones that'll fit. And you get those little plastic closures and you snap them in place over those spots. Also in your panel board, you must identify any spare breakers. So if I have any spare breakers in there without loads connected to them and they're just breakers mounted in there, I have to identify them as spares, right? All part of making sense when we read that circuit directory, doesn't it? Right? Orientation, my panel boards must be mounted vertically. And I think there is one exception, isn't there, on some laundry equipment, commercial laundry equipment, where you can mount a panel board horizontally. But to tell you the truth, I'd have to go look it up. I'm not familiar with it. Good homework problem for you, right? Maybe I'm wrong. Anyway, panel board orientation, the way that we're going to mount them is vertically, have a good circuit directory, make sure we follow the requirements, true and plumb, professional and skillful manner and all of that, which is going to take us into the next section, wiring, okay, installation. What about some installation and wiring techniques that we have to consider when it actually comes to installing these panel boards? And I made a little list of some of the things that might apply, so let's talk about those. One is what I just mentioned. 110.12 says that my work must be done in a professional and skillful manner. What does that mean? It means I follow the code requirements, I follow the manufacturer's instructions, and to me it means I take pride in my work. If I've got a conduit run coming in here, it meets all the code requirements. It's properly supported. Any bends are nice and well done, right? No problems with my bends and all of those type things. All my offsets look good. If I've got some concentric bends, they look nice and neat. And boy, I'm thinking of all the pretty pictures we see on social media of electricians taking pride in their work when it comes to things like conduit bending are all great. But anyway, so I make sure that I install my equipment professional and skillful manner. And why? Safety, okay? It's all about safety. Everything we're talking about is what? The practical safeguarding of people and property from the hazards arising from the use of electricity. So if I don't do things, for instance, 110.14 says I have to torque my terminal connections. All of those requirements don't say, well, I don't know what they should be. No, look on the breakers, they'll tell you. Look in the labeling inside the panel board. It will tell you what the torque requirements are for the different termination screws. Follow those requirements. If I don't apply enough torque, I obviously have a problem. Something could come loose, or I could have an overheating problem from too much resistance. If I over torque, I create additional problems as well. Conductors can loosen underneath a terminal screw, and once again, you know, the ultimate thing to go wrong would be to have a fire, and we certainly don't want that. So follow your torque requirements in 110.14. Oh, 240.4D is another important one. It's 240.4D. Article 240 is on overcurrent protection. So .4D talks about, for instance, on a 15 amp breaker, what am I going to use? 14 AWG wire. What am I going to use on a 20 amp breaker? 12 AWG and so forth. So take a look at 240.4D if you get involved in installation of overcurrent protective devices. Fuses are circuit breakers inside of panel boards. Multi-wire circuits. So multi-wire circuits are talked about really 210.4, Article 210 on branch circuits, and then Section 4. So 210.4 is on multi-wire branch circuits. So a multi-wire branch circuit, if you can tell, I've got a circuit breaker up here. It's actually manufactured together. It is one unit, right? Can't take them apart. It's two single pole breakers put together by the manufacturer, and if I operate, there are handle ties on it. If we have to install them, we have to make sure we use what's called identified handle ties. Anyway, let's move on to the next topic then. 408.37 says that if I'm going to install my panel boards in a damp or a wet location, I got to go back to Article 312, Section 2. So 312.2 talks about installation, damp and wet locations then. Another item, 110.26. 110.26, spaces about electrical equipment. Bottom line, when I come in here to work on this panel board, I got to have enough elbow room. I don't want to hit my head on anything. I don't want water dripping on top of me. And from this panel board to out here, what's behind me, what are those distance requirements? That's all found in 110.26. There are tables based on whether I have an uninsulated wall, an insulated wall, or another piece of electrical equipment with a certain voltage, how much room I have to have between those two pieces of equipment or between that panel board and that wall and so on. Spaces about my electrical equipment, height requirements, no water dripping down, drip pans, all of those requirements I find in 110.26, as well as your storage requirements. Inside of this working space that I have to be able to get in there and work safely on the equipment, I don't want to have to step over something or trip on something, so storage is not permitted within that working space. And I know you've never seen a violation of that requirement, right? And finally, check out 240.24. 240.24, Article 240 on overcurrent protection, and 240.24 talks about my overcurrent protective devices have to be readily accessible. I got a definition in Article 100 for readily accessible. It also tells me that the center of the grip, from the center of the grip of the operating handle in the up position, can be no more than 6 feet 7 inches from the floor. So check out all your requirements in 240.24. So anyway, that's panel boards in a nutshell, isn't it? We talked about general information, definitions, marking requirements, requirements for the circuit directory. We've looked at the guts of the enclosure and looked at the panel board itself, talked quite a bit about that. And we talked about some of the installation techniques that are found elsewhere in the NEC other than Article 408 as well. So take a look at all of that. Make sure that when you go out of here, you work safe.